So let us see some of the practical examples of inertia, right? Up to this point, we learned about inertia, and in that case, we saw that inertia is nothing but the property of any body which has mass. So first of all, you need to keep in mind that if any body has some mass, that object is bound to have this property called as inertia. All right. And if that body is having some mass, which is it is having also some inertia, that means it is having the property to resist any change in its motion. All right. Remember, I'm doing an emphasis on change, because if some object is already in a state of motion, this object wants to be in that state of motion. So if you try to apply some change in that, that object will try to resist it. Okay, this property of any body is called as inertia. Now let us see some actual examples. For example, traveling in any vehicle. Here, if I take the example of a bus, all right, and you are standing in a bus like this, and this is the driver who is driving this, all right. Now the driver suddenly starts to accelerate in the forward direction. All right. So the motion of the bus is in the forward direction, and he suddenly starts to accelerate it. First of all, can you tell me that in which direction your body is going to move? All right. You might have some practical experience with this as well, right? So tell me in which direction the body is going to move. Yes, your body moves in the backward direction. Suddenly, if something accelerates in the forward direction, your body moves in the backward direction. Why? What is the reason behind this? Okay, so let's see. In this case, tell me initially, let's say if the bus was at rest, all right? So this means your body is at rest, okay? With this property of inertia, your body wants to stay in this state of motion, which is rest, okay? This means in this case, once again, if the driver is trying to move in the forward direction, here the change in motion or change in state of motion is in the forward direction. All right. The change is in the forward direction. Therefore, your body will try to naturally oppose this change. How will it do that? It will do by making the body go backwards, so that you do not want to go in the forward direction. Your body has some inertia. As a result, your body automatically goes a little bit backwards. Okay, isn't that amazing in this case? So due to inertia, this is the reason that if someone accelerates suddenly in the forward direction, your body moves backwards. If this bus driver suddenly applies brakes, okay, so you were already in motion, right? As of now, the bus is going in the forward direction, right? So you are in motion as of now, and your motion is in this right direction, or let's say forward direction, and the driver suddenly starts to apply brakes. Now if he's starting to apply brakes, due to that, remember, change in motion, all right? So the change here is in the backward direction, all right? So the change in velocity, or basically change in motion, the acceleration is in the backward direction. As a result, look at this, your body wants to keep on moving in the forward direction, but because of this particular change, this inertia of your body is going to push your body in the forward direction. So your body moves forward when the driver applies brakes. All right. This is true for any other vehicle as well. If you're on a bike or in a car, suddenly if someone applies brakes, your body comes forward. All right. This is the reason behind, and the reason behind this is actually inertia. This is why we use safety belts. Remember that in cars, we usually have safety belts or seat belts, which are used to protect you from falling forwards in the case of an accident. In an accident, the car's change in motion is very sudden and very quick. As a result, your inertia throws your body in the forward direction, because your body wants to keep on moving in the forward direction. Okay? And to protect you from that, you have safety belts. Sharp turn in a vehicle. See, even in that case, you might have observed that, for example, a car is moving in this forward direction like this, and the car suddenly takes a sharp turn in this direction. Okay, the car is turning in this direction, but your body moves a little bit outwards. Your body's motion is in this direction, outwards, as soon as the car is turning, right? but the car's motion is in the opposite direction. See, once again, the reason is your body wants to keep on moving in the forward direction. You do not want to change even your direction of motion. Okay, that's how brilliant this inertia is. And as a result, your body tends to move in the forward direction, keeps on moving in this opposite direction because of inertia. Okay, last example, stack of coins or on the carom board, right? You might have played carom board in which there are a stack of coins like this. Okay, now on this stack of coins, let's say you have the striker and you're making the striker on this bottom coin. All right, as soon as you hit the striker on the bottom coin, if the speed of this striker was good enough, this bottom coin suddenly moves in the forward direction. But if you have good enough speed, the rest of the stack of coins stays in that place. They do not move. And the reason behind this is they were in the state of motion which was basically rest. All right, they were in a state of rest. As a result, they want to be in state of rest, and because although there is a tiny bit of force applied on them, they want to stay in rest because of inertia. They are already stacked up like this. They do not fall. All right, and the reason behind this is once again inertia. All right, so these are some of the basic examples of inertia. Now let us see the relationship of inertia and mass. All right, now see, mass is how much matter is there in some amount of volume. All right, and in this case, if the mass is really high, all right, that means in those situations actually it becomes a little bit higher to move those body or difficult to move those body as well. In this case, this bucket is full of sand and this is an empty bucket. Very simple question. If I ask you that which bucket is easier to push, basically this bucket is easier to push, all right, because it has less mass. This bucket has higher mass, right? I can simply say that M2 is greater than M1. Now, if M2 is greater than M1, in this case, I need to apply more and more force to change its state of motion. So, as the mass goes high, the force required to change the state of motion of that object also goes up. All right. As a result, we can simply say that mass is the measure of inertia. All right. Remember, mass and inertia are not the same. Inertia is just a property of the body, and mass is basically the how much matter is there in any specific volume. All right. So this means in this case, if you want to find out how much inertia this has, I can directly relate it to the mass. That is, if higher is the mass of the body, higher will be inertia. So that means here, if this is a huge car and on the other hand, if you have a bicycle like this, all right, it will be much easier to move the bicycle because its mass is also less. All right. On the other hand, for this car, its mass is going to be really high, and as a result, to move that or just push that with your hands is going to be a difficult task. Okay, so this is the difference or the similarity between inertia and mass. Thank you. So here we are going to begin with quantity of motion, right? Or basically measure. Hello students. So here we are going to begin with measure of quantity of motion. All right. Now, in this case, first of all, let us consider two examples. All right. Here I have a truck and then there is this bicycle, and both of these things are moving in this left direction. All right. Now, this bicycle is moving with a speed of 6 km per hour. All right. So this speed is not that much. Apart from this, this truck is also moving in the same direction with the same speed, which is 6 km per hour. Now, a very simple question is in front of you, which is you're standing here and these two things are moving towards you. All right. Now, can you tell me out of these two things moving with the same speed towards you, which object has more danger to your life? Obviously the truck, right? Now, But the thing is, both of the objects are moving with the same speed, or let's say in this case, because the direction is also same, I can say both of them are moving with the same velocity. Then what is it that the truck is posing more and more danger to your body instead of this bicycle? Let's say you get hit by this bicycle, God forbid, I hope that you never do, but if this happens, you will have some damage, right? Obviously, that won't be life threatening. On the other hand, this truck, that is a very worst case scenario. The reason behind this is the truck is way too massive as compared to this bicycle, right? But tell me, if this truck and the bicycle are now at rest, okay? None of them are moving here. So which of the two things pose more danger to you? None of them. They're not moving anywhere. They are at rest. Alright. So this means in this case, when nothing is moving or any object is not moving, in this case, whatever the mass of the object is, with respect to the motion of the object, there is no danger. Alright. So this means whenever some object moves, speed is important for here 6 km per hour, right? So the amount of speed is really important, but the thing is, its mass also needs to be taken into account, right? Because if something very massive is moving, even with the slow amount of speed, that object can cause a lot of damage, all right? So let's see where we're going to head with this. But before that, look at the similar example with a gun and a bullet, all right? Here, this gun has some mass, right? Let's say that is mass m1, and this bullet also has some mass, which is mass m2. Now the bullet is fired from the gun, but the thing is, the mass of bullet is way too small as compared to the gun. I can simply write m2 is going to be very less than m1, right? But in this case, the gun's velocity is going to be negligible. It's not going to move here and there substantially. On the other hand, the bullet is moving with the very high speed. Okay, so the velocity of the bullet is very high, although its mass is less. So this means in this case, even if this gun directly is thrown at someone, it won't cause as much of damage. On the other hand, this bullet, although having a very tiny mass, but moving at a very high velocity, can cause deathly or basically deadly damage, which is very important in this case to note that although mass is less but velocity is high, the object can still cause a lot of damage. All right. So this means here we are going to define a quantity which is known as momentum. All right. And this momentum obviously depends on the velocity of the object as well as mass of the object. Okay. So let's see how this quantity is related. Now, see, momentum is denoted by the letter P. All right. And of any object, this momentum is defined as the product of the object's mass and velocity. Okay. So this means momentum's formula can be written as P, which will be equal to mass m multiplied by the velocity v. All right. Here, let's try to find out the SI unit. Look at this. This is P, which is momentum, equal to mass into velocity. What is the SI unit of mass? SI unit of mass is kilogram. This should be multiplied with the SI unit of velocity, which is meter per second. All right. So this is going to be kg meter per second or kilogram meter per second. All right. So remember, SI unit of momentum is kg meter per second. Now this momentum has both magnitude as well as direction. Can you think of the reason why? Yes. See, in this case, this is mass times velocity. And what is velocity? Velocity is a vector. Okay. Now, as velocity is a vector, in this case, momentum is also a vector. So this means the direction of momentum of a body is in the direction of velocity. So for example, here any object is moving in this direction, the mass of the object is m and it is moving with a velocity v in the right direction. Therefore, the momentum of this body is going to be also in right direction. All right. Okay. Now, application of an unbalanced force brings change in the velocity of the object. This is something we know. which is basically if an object is moving in this direction. Remember, a force can change the speed of the object as well as force can also change the direction of motion of the object. Now, if the force is able to change either magnitude or direction of motion of the object, in that case, we can simply say that the velocity is going to change. Alright? Now here, remember that in this case, if the velocity changes, look at this, what is the formula? P is equal to mv. If the velocity is going to change, that means momentum is also going to change. So here, we can simply say that if you apply an unbalanced force on any object, it is possible that that unbalanced force can change the momentum of the object. Alright, keep this crucial point in your mind. Alright, and here we begin with, after this we will begin with second law of motion. Alright, I hope you have understood about momentum. Remember, it's a very simple quantity. It is nothing but the measure of motion of an object. Alright, if an object is moving, the object has some mass and the object is moving some velocity. In that case, if you want to find out the momentum, what you will do? You will simply multiply the mass with the velocity of the object. Now, I'll leave you with a simple question. Tell me, if the object is at rest, what is going to be its momentum? Alright, think about that. I'll answer this in the next video and keep learning with Easyhai Online.